But I think that's probably one of the reasons I'll never win the Golden Apple Award. You know, like Teacher of the Year, like I'm never gonna win that. Unless you nominate me, Ilya. Are you gonna nominate me? Promise? You're shaking your head.
Yeah.
You have to now. And then everybody has to vote for me. All my 270 YouTube subscribers. Get them all to vote for me. Maybe I can win the Golden Apple Award then. Probably not though. You know what it is? People don't like me because they don't like math. You know? This is the quintessential, and I don't know if people say this anymore, if it's an outdated saying, like don't hate the player, hate the game. Like that sort of thing. Like that's how I feel. If people don't like me because I make them do math, and math is not fun all the time, don't hate me. You can hate this, that's fine. Direct your hate here, right? Not here. All right, anyway, so solving trigonometric functions, we have a flow chart where you have a choose your own adventure, right? Try to write all terms as variations of sine, cosine, or tangent, no mixing and matching. This doesn't have any of those, right? But it can, okay? Keep in mind that this is really this, okay? It's just an abbreviated way of writing that. And cosecant, and I'm going to jump down here, can be replaced with 1 over sine. So now this statement would look like this, okay? Now, because I'm trying to follow the flow chart that I authored, right? This is my creation, right? This didn't come from a textbook. This was my idea. And I said, try to write everything in terms of sine, cosine, or tangent. Because that was my idea, I'm going to try to stick to it. But really, in this problem, it would be easy to isolate cosecant first, and then substitute this in its place. Because writing this over and over and over again is going to get cumbersome. But sticking with the flow chart and sticking with this problem-solving process. Okay, we've done that. Does this equation have a squared trig term and a non-squared trig term? No, it just has a squared trig term. So we come over here. Now, eventually, like I believe on the next problem, we're going to go this way. Okay, which is exciting, right? It's like, ooh, it's a new event. I'm just kidding. You guys, never mind. Use inverse operations to isolate the trig term. So that means get this by itself. Right? We see that trigonometric package as the variable that we need to solve for, this whole thing. Okay? So the first thing we're going to do is add 4 to the other side. Now I have this. Then I'm going to divide by the 2 that's in front. I'm going to cancel that. That 2 is being multiplied times this quantity, which I'm solving for, so I'm going to divide by 2 and cancel. So now this says 1 over sine x squared equals 2. Still don't have that trig term isolated because there's a squared with it. So I'm going to take the square root of both sides. Now it's 1 over sine x equals, and we talked about this in a previous problem. When you have to do the operation of square rooting both sides of an equation, you have to include both the positive and negative outputs of that. Now, the square root of 2 is just the square root of 2. So now I'm here. And now I have isolated the trig term. Problem is, it's down here. If you go back and you look at all of the problems, we've done problems like this. Let's see if I can find it. Bang. Okay, we've done a problem like this before. So we're in a spot right now in the problem that we're looking at very similar to this spot. Okay? what did we do when we were in that spot? We did the switcheroo. That variable that you're solving for is in the denominator of a fraction. We swap it out with something that's over here. Okay? So we're going to take what's on the other side of the equation and we're going to switch it with the sign that's down here. Now when we do that, we have to bring everything. We have to bring all of this. And we're going to put it down here, and then we're going to take this, and we're going to move that out. So we have, and I'm going to write the plus or minus in front now. So now my problem looks like this. The sign has been isolated. Yay! However, as we've seen before in some of these videos, we can't leave a radical 2 in the bottom. So we're going to rationalize that by multiplying by radical 2 on the top and the bottom. Now it says plus or minus radical 2 over 2 is equal to sine x. Now, finally, we have our trigonometric term isolated. We have it equal to something here, and this something here is a number that we should be that we should recognize from our experience on the unit circle. So, again, the flow chart. We did this. Yes, we did have to take the square root in order to do that. Now find the angles on the unit circle that have these values, meaning, oops, what happened there? There we go. Meaning, there's some angle. The answer to this question is x, right? This is an angle. And because we're doing sine, these are y coordinates. So what angles have y coordinates of plus or minus radical 2? Those are all of our pi over 4 angles. Pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. I'm including all 4 of them because we want positive and negative outputs there. We can say positive radical 2 over 2, the y coordinates of pi over 4 and 3 pi over 4 are positive radical 2 over 2, and at 5 pi over 4 and 7 pi over 4, those y coordinates are negative radical 2 over 2. So when we see the plus or minus, we're going to have 4 answers down here. Okay? Check mark.